Assalamu alaikum and very good evening to everyone. Myself, Dr. Parvez Ahmad, working in the Department of Mechanical Engineering, B.S.Abdur, Crescent University. I wholeheartedly welcome you all to this wonderful FDP. Now, it is my privilege to introduce our guest speaker. Um, he is going to present on the topic of applications of hydrogen fuels in engines. Dr. Manzoore Elahi Saudagar is a distinguished associate professor in the College of Engineering at Li Shuqi University, China. He obtained his PhD in heat transfer energy from the Department of Mechanical Engineering at the University of Malaya, Kuala Lumpur, Malaysia, which is ranked 65th internationally by QS World Rankings. Dr. Saudagar's research encompasses a variety of advanced domains including biofuels, nanotechnology, composite materials, and solar engineering. He has an exceptional academic record, having written and co-authored more than 270 articles in high-impact journal indexed by Web of Science. Besides journal publications, he has contributed to many conference proceedings, book chapters, and patents. His academic impact is evident in his Google Scholar profile, which has over 8,900 citations, and H index of 53 and I-10 index of 150. Dr. Saudagar has been acknowledged as one of the top 2% of highly cited researcher worldwide by Elsewhere Scopus and Stanford University for 3 consecutive years. He has been honored with esteemed Young Scientist Award from Science Literature MDPI, achieving a rank of 29th among 5,500 scientists in China. Beside his research accomplishment, Dr. Saudagar serves as an active reviewer for prominent journals published by Elsewhere, Springer, Nature, Wiley, Taylor and Francis, and AIP journals, having evaluated more than 500 publications and serves as guest editor and associate editor of WOS journals, Web of Science journals. So, with this brief introduction, I wholeheartedly welcome you all, and I would like to request our speaker to take over the session.
Good evening, everyone. Dear eminent faculty members, research scholars in India, my name is Manzoore Elahi Saudagar, and that was a very nice introduction about me by Dr. Parvez. And it's an honor to be invited here today to share my insights on a topic that is shaping the future of the sustainable transportation, like hydrogen and biofuels. My expertise lies in the renewable energy systems and sustainable technologies, and my research has often focused on interplay and their practical applications in the modern industries. This includes work on energy optimization and hybrid power systems, some of which I have published in leading journals and shared at international conferences. The rise of hydrogen and biofuel vehicles is not only a technical breakthrough, but also a step towards a greener planet. In this talk, I'll be exploring the basics of hydrogen vehicles, which can be run on the IC engines, and technical research of biofuels and future prospect of these vehicles. I thank the organizers of these wonderful opportunities and look forward to engaging discussion with you all. So let's begin. So I'll just take 1 minute to introduce myself once again. So I am ranked as 2% scientist from from the Stanford University and Elsevier Scopus from the year 2022 to 2024 among 15 million active researchers in the world, and my rank was around 40,000. And up till now, I have published more than 300 Web of Science papers. And also my Google's scholar citations are more than 9,000 with a H index of 53. I serve as associate editor of Frontiers of Energy and Frontiers of Mechanical Engineering. And also I have served as guest editor of Materials, Energies, Sustainability, MDPI, Elsevier Tech Science. And also I have reviewed several, like 500 articles indexed in Web of Science. And presently I'm working as Distinguished Associate Professor in the College of Engineering at Lishui University in Zhejiang province in China. So we will start with these contents. First one is an introduction to hydrogen in the IC engines. The talk, the faculty development program conducted by ATAL AICTE. Actually, what I understand by the faculty development program is to develop the faculty members to do the research. So I'll not be talking specifically on like hydrogen energy or electric vehicles or artificial intelligence. So I will talk on the research, recent research which I have done. So I'll just start with the brief introduction on the hydrogen energy in the IC engines. Then I will come to a very trending topic like biofuels and nano additives. I will explain this in detail, and a very basic topic which you all are interested in, like how to start with a research paper, how to write a very nice research paper which can be published in a high impact factor journal. So I will start a basic introduction to the hydrogen in the IC engines. So as you know all, like hydrogen is the most abundant element in the universe, making about 75% of its elemental mass. It is colorless, odorless, tasteless, and highly flammable gas with a molecular formula of H2. You can see here link of two hydrogen atoms. And also it has the atomic number of 1. And it has the highest calorific value that is very suitable for an engine. And also the sources of hydrogen energy are the water. It can be generated, the hydrogen can be generated from water and hydrocarbons and biomass and organic matters. And hydrogen in internal combustion engine. So basically we use the gasoline, we use the diesel, we use the biofuel, etc. So there is research going on since the year 1966 on the hydrogen in internal combustion engine. Since the hydrogen is very cheap and it has the highest calorific value and it generates negligible, like no emissions. Okay, so hydrogen has recently gained as a transitional technology towards cleaner energy. So hydrogen and internal combustion engine utilize hydrogen as a fuel source while leveraging existing internal combustion engine technology with modification to accommodate the unique properties of hydrogen. So what are the advantages of hydrogens in engine? As I told you, it is it generates zero emissions, zero carbon emissions, and hydrogen can be produced from diverse sources, including water electrolysis using renewable energy. And also the performance basis, hydrogen has a high energy to weight ratio, enabling efficient energy utilization in the transportation and industrial application. You can see a photo of a BMW car, that is old car, that was manufactured in 2007. So now the research is going on, further research is going on in the BMW to produce more hydrogen energy run engines. So hydrogen energy powered internal combustion engine, this one you can see here, and it runs on dual fuel engine, and it has a 6-liter V12 with a modified to burn hydrogen. And the performance, it produces 260 horsepower, and also the range is about, in one fuel cell it can run about 500 kilometers. And also the key features of hydrogen in IC engines. So again, these are some of the advantages. High combustion efficiency, hydrogen's wide flammability range, like 4 to 75% in air, and high flame speed enhances combustion efficiency. And yes, as you know, it has the clean emissions, zero carbon dioxide, carbon monoxide or sulfur dioxide. But however, there is an increase of NOx emission, which can be controlled by utilization of exhaust gas recirculation unit. And also, it will avoid unnecessary parts. So it has the in the engine, there is like little bit modifications to fit the hydrogen inside the internal combustion engine. And hydrogen has a high energy to weight ratio, making it advantageous for applications where weight is a concern. And also hydrogen storage and delivery. So hydrogen is stored either, this is very important. There is ongoing research on storage of hydrogen storage and hydrogen generation. This is a very trending topic. So you can like hydrogen storage and delivery. So you can also write a review article or a research on this hydrogen storage and delivery. So hydrogen is stored in either compressed gas form at 350 to 700 bar or as liquid hydrogen at minus 253 degrees centigrade. Fuel derivative system in hydrogen and internal combustion engines require materials that resist hydrogen embrittlement and ensure safe transport to combustion chamber. So there is certain engine modifications, very few engine modifications required for the hydrogen for a dual fuel engine. Dual fuel means, for example, a car runs on the diesel engine and we use the hydrogen also in the engine. Like in the recent, you can see the car runs on the petrol and also on the electric. So it is known as the hybrid car. So here, engine modification for the hydrogen. So intake system. So intake system can be modified. So manifolds can be modified to prevent pre-ignition. So since it has a very high calorific value and higher like flash point, so the intake manifold should be like modified, and direct injection or port injection system specifically designed for hydrogen's low ignition energy. And I'll come to this one, wide range of flammability. So hydrogen has a wide flammability range in comparison with all other fuels. As a result, hydrogen can be combusted in an internal combustion engine or a wide range of fuel air mixtures. A significant advantage of this is that hydrogen can run on a lean mixture. So when we use the biodiesel, for example, in the internal combustion engine, it doesn't have a lean mixture. For making it lean mixture, we mix little bit of biodiesel and more of diesel. So there is no such problem in the hydrogen run engine. So since it is lean mixture, so it can ignite very randomly and rapidly. And a lean mixture is one in which the amount of fuel is less than the theoretical, stoichiometric, or chemically ideal amount needed for combustion with a given amount of air. So generally speaking, fuel economy is greater and the combustion reaction is more complete when a vehicle is run on a lean mixture. Additionally, the final combustion temperature is generally lower, reducing the amount of pollutants emitted in the exhaust manifold. So you can see some of the challenges of using the hydrogen in the internal combustion engine. As I told you previously, it reduces all the emissions, carbon dioxide, carbon monoxide, particulate matters, etc. But there is a rise of nitrogen oxide. Why? Because of like when more oxygen is supplied, so there is more nitrogen dioxide emissions. So there is solution like using the exhaust gas recirculation and lean burn combustion strategies. And also pre-ignition, there is other challenge as well, pre-ignition and backfire. So since it is very combustible, so it can ignite very rapidly. So it can be optimized injection timing. So there is an injection timing and injection pressure. So injection timing 23.5 BTDC, we can change it to certain different angle. Okay. And also using the cooling system and low volumetric energy density. like advanced storage methods like metal hydrides or liquid hydrogen. So these are the challenges and these are the solutions of using the hydrogen in the internal combustion engines. And these are the applications beyond the transportation. So hydrogen can be used recently in the aviation, maritime. Maritime is like in the ships and also the stationary power stations. And these are some of the examples of the hydrogen run. This was the first ever hydrogen built engine known as GM, General Motors Electro Van, that was manufactured in the year 1966. So this is a hydrogen fuel cell vehicle. The General Motor Electrovan was powered by a fuel cell which used hydrogen and oxygen to produce electricity. It has a range of approximately 150 or 300 kilometers on a single charge of hydrogen, and there is zero emissions. But the challenge is it's the bulkiness of the the vehicle, because to store the hydrogen and etc. and high cost and lack of hydrogen infrastructure made it impractical for the mass production. So it was dropped. But however, like recent research going on the hydrogen vehicles has developed several different hydrogen vehicles like Toyota Mirai and Honda Corolla run on the hydrogen. And these are some of the other like recent examples of the hydrogen vehicles. So, this is the main like hydrogen fuel cells in the engine. So through the fuel cells only, the hydrogen, like the internal combustion will run on the hydrogen, can be used as the fuel, like hydrogen fuel. So a fuel cell system convert hydrogen into electricity via electrochemical reactions to power electric motors. This approach is efficient and emission-free, offering advantages over conventional internal combustion engine. So, the fuel cell technology, this is the recent one. Proton exchange membrane fuel cells are widely used due to their quick startup and high efficiency. And energy efficiency of this is like fuel cells achieve 60 to 70% of the efficiency, significantly higher 30 to 40% that was achieved by internal combustion engine run on diesel. Okay, this is the recent example, Toyota Mirai. So it offers a range of one fuel cell can offer a range of 650 kilometers, and refueling takes only about 3 to 5 minutes. So just put the oxygen, like refuel the oxygen for 3 to 5 minutes and run for 650 kilometers at a stretch. And the hydrogen energy is very cheap. Like hydrogen is very cheap to manufacture and also produces and also green, like it like no carbon emissions and good for the environment. And this is one example, and this is another example. This is hydrogen Corolla. And these are some of the methods for producing the hydrogen energy. So hydrogen energy can be produced by the methane gas. When the, you can see here in the diagram, when the methane gas reacts with the water, it produces carbon monoxide and 3 atoms of hydrogen. And further, when it reacts with the water, when the carbon monoxide further reacts with the water, it produces the carbon dioxide and hydrogen. So first here we supply in the reactor, we supply the methane gas, and the methane gas simultaneously with the water. So here it converts into carbon dioxide and nitrogen oxide. That is the secondary product, nitrogen oxide. And this one here, in the second stage, the carbon monoxide that is produced and it is further reduced. Carbon monoxide with the water, it produces carbon dioxide and hydrogen. So one of the it is the most used and most common and cost-effective method for hydrogen production. And one of the major drawback that it produces carbon dioxide emission unless combined with carbon capture. and CCS technologies. So the second method for production of, this is very simple, electrolysis of water. So this is anode and cathode. And when the electricity is supplied to this reactor, so it dissociates, the hydrogen atoms dissociate with the oxygen atoms. So here on the left side, the oxygen, like it goes out, and here you can produce the hydrogen. This is a very simple. And when it is prepared, when the electricity is supplied from the renewable energy such as solar, wind powers, etc., so it is known as green energy, since it do not use the electricity produced from the coal or something like that. So this is the green hydrogen. It is known as the green hydrogen. And another process of preparing the manufacturing the hydrogen is the biomass gasification. So in this process, organic materials such as biomass are heated in the presence of limited oxygen to produce a gas mixture. It is known as syngas, containing hydrogen, carbon monoxide, and methane. So the hydrogen is separated from the syngas through further processing. So you can see here reactor. So since we have very less time to cover all the topics, so I won't be covering this in detail. And one more is the solar thermochemical hydrogen process production method. And this one, these are the metal oxides. Okay, these are the metal oxides. In a container, it is heated by the sun, and it dissociates into like the metal oxide and the oxygen atom and the hydrogen atom, and the hydrogen is separated and the oxygen is separated. So these are some of the processes to manufacture the hydrogen. And hydrogen can be used as a dual fuel, since I also study, my research is also, basically my research is on the biofuel. So we also published papers, several papers on the dual fuel engine, and for example, the producer gas, the biofuel with the hydrogen. So I'll just tell in brief about this. So combustion process ignition. So this one, the first one, biofuel acts as the primary ignition source. Their cetane number ensures reliable ignition under compression. Hydrogen, being a secondary fuel, supports combustion by enhancing flame propagation and improving thermal efficiency. So second phase is the combustion phase. So there is a pre-mixed combustion. The hydrogen and air mixes. A mixture ignites first due to its high flame speed and high flammability. First, the biofuel is injected into the system, then the hydrogen ignites the biofuel and ignites itself, and there is heat release in the engine, and that's the process goes on. So, and the heat release, I'll just tell in a brief. Hydrogen's high combustion temperature leads to a faster heat release rate. Biofuels add stability to the combustion process, reducing the risk of knocking. And also, when the engine is at high load, more hydrogen should be supplied, because it will take more energy, and at low loads, low hydrogen supply should be there. So you have to remember this when you work on the dual fuel engines in the future. And I will come to the next topic, which is one of the trending topic as well. So biofuels and nano additives, a detailed study. I will explain this in very detail, And this is the scope of the research. As you know, there is increase in the pollution, increase in the population. As the population increase, there is more pollution. As you know, I'll tell the example of China. China was one of the most populated country in the world. Now India overtook China in the population, but the demographic of China is 3 times bigger than India. And there is, when I go out, I can breathe in some clean air. in China, because they utilize the batteries, and there is no pollution at all, no pollution. So, but in India, there is no such regulations on the pollution, and so the government should implement the pollution regulation by using more of the greener fuels such as hydrogen or biofuels, or the battery operated cars, EV, electric vehicles, etc. So there is rising fuel. India is the biggest importer of the oil, because of the population, because of the rising population. So the fuel dependency on the other countries such as Iran, Saudi Arabia, etc., or Venezuela, from where we import the petrol, gasoline, diesel, etc. So it will be reduced, and that is the best solution is to use the renewable energy sources such as the biofuel or the hydrogen or wind, solar, etc. So biofuel, as you know, consists of few drawbacks such as high viscosity, lower calorific value, uh, and like several other drawbacks it has, and higher viscosity, and this can be reduced by addition of nanoparticles. This is not a new topic, like maybe it started 10 years ago, but it is still trending, and it is in the research field. So there is a very nice scope of publishing articles in this field, and hydrogen storage, as I told you. So I'll go further on this. So as you know, biodiesel is a renewable biodegradable fuel made from natural oils or fats such as vegetable oils, animal fats. As you know, India is covered by forests, and there are several trees, and several trees produces several seeds, etc. Several seeds. So the seeds can be collected, and it can be through the oil can be extracted through the seeds and can be used as the biofuel. For example, you can see so many in the South India, Pongamia pinnata, honge, or the jatropha, or many other trees, and the animal fats, for example, the chicken fat or the lamb fat, or some animals. So that fat can also be anything which has the oil, which has the free fatty acid, can be converted into biodiesel. And even the recycled cooking oils, in India, it's not it's a taboo, like they use again and again and again recycled oils, but after 2 or 3 uses, just you have to throw the oil. So the cooking oil can also be converted into biodiesel. So it is a cleaner burning alternative to petroleum based diesel, and can be used in diesel engines with little or no modifications. So biodiesel is produced by a very simple chemical reaction known as transesterification reaction, so that it converts into FAME. It is known as fatty acid methyl ethers. So some of the advantages of biodiesel are environmental benefits. It reduces the green gas emissions, emits fewer particulate matters and sulfur dioxide. It is a renewable made from sustainable sources such as I told you, vegetable oil, animal fats. No synthetic things are used here. And compatibility, it can work with the existing diesel engine without any significant modification. And these are the applications of nanoparticles in the biofuels. So it improves the combustion efficiency, acts as a catalyst to accelerate combustion reactions. It ensures complete fuel combustion, reducing unburnt hydrocarbons, and it reduces the ignition delay. That is the main thing. And also the emission reduction, it lowers the nitrogen oxide emissions, carbon monoxide, and particulate matters emissions by promoting efficient combustion, and enhances the soot oxidation, minimizing particulate emissions. And also it has the higher calorific value, And also some of the antioxidant properties of nanoparticles such as cerium oxide extend the biofuel shelf life. When you keep the biofuel for a certain time, it starts to agglomerate. Okay, the compound starts to settle down. So it can increase the shelf value as well. Some of the examples of like the nanoparticles are cerium oxide, aluminum oxide, and carbon nanotubes. The recent like the advancement also used in since I did my research in Malaysia, there is a new nanoparticle that is trending, that is known as Mexene, MXENE. That also can be, because no one has done the research on this. So also that you can, if you're interested, you can use those as well. And this was the scope of the studies which we did. So, when you use the neat diesel, there is fossil fuel depletion. And when you use the straight biodiesel or the neat biodiesel, there is a high density, lower calorific value, high viscosity, lowered energy content. And when you use the binary blends such as diesel alcohol, there is a mixture stratification. So the diesel will like float or the alcohol will float, and there is no like blending of each other. So like we combine the the biofuel, the diesel, and the nanoparticles to make a high performance fuel. And this is the research aim of using the biofuels. So the use of diesel and biodiesel fuel blends in engine application results in large quantity of noxious emissions, as I told you. So diesel and biodiesel, because it doesn't burn. Sometimes the biodiesel, since it has the low calorific value and high viscosity, it doesn't burn properly. So to improve the calorific value, reduce the poor cold flow properties. So there is a need of adding some additive. It may be some liquid additive or some nano additive. Nano additive, when you use, you can use in like very part ppm or mg per liter, very like 40 milligram per liter or 60 milligram per liter or 100. Just it will be very negligible in 1 liter of a B20 fuel blend. So the addition of nano additives in biodiesel fuel increases the micro explosion process. It reduces the ignition delay, increases the heat transfer. And also in the research, what we did, so we modified the combustion chamber, toroidal combustion chamber, and toroidal re-entrant combustion chamber we used. And also we used, instead of 3-hole like micro orifices in the fuel injector, we used the 6-hole or 7-hole for the like better mixing and better spray penetration, uniform distribution of fuel air mixture. And the objective of the study, what we did the research, I'll show you the like some of the papers which was published here. So you can see this is the paper, this is the review article. This was published on the effect of nano additives and diesel fuel, a comprehensive review, which gained a citation of 430. And this is one of the research article which was studied on the dairy scum, waste dairy scum. It was studied in Karnataka. And since I belong from Karnataka, so I am also from South India, Karnataka. So I studied the dairy scum in Karnataka milk factory, and I produced the biodiesel from the waste dairy scum oil, and like put the nanoparticles, and it like published in the journal Fuel. And also aluminum oxide with the nano additives, and in published in the renewable energy. Several, you can see all these articles. This is strontium coated zinc oxide nanoparticles. So all these are studied, all the articles which you can see of the 100 citations, more than 100 citations are of the nanoparticles, since it is a trending topic nowadays. So I'll continue with this one. So the objective of our study is to produce biodiesel from different biodiesel feedstocks and to check their feasibility as an alternative fuel source in four-stroke diesel engines. And the second objective is the synthesis of nanoparticles. Nanoparticles are also commercially available, but the thing is we synthesize the nanoparticle by the chemical vapor deposition, sol gel method, aqueous precipitation method, etc. And there was like to find whether the nanoparticles are properly synthesized. We used several characterization methods such as scanning electron microscopy, like transmission TEM and XRD, EDS, FTIR, UV-Vis, etc. And the third objective to determine the performance, emission, and combustion characteristics of a four-stroke. This is a normal conventional mechanical fuel injection diesel system. And the fourth objective, the same objective, is to determine the performance, emission, and combustion characteristics of a nano-fuel blend with CRDI engine, Common Rail Direct Ignition System. Okay, and this is the literature review. So this is published in a journal known as Energy Conversion Management, which has an impact factor of around 10. So we studied, this is a literature review. So selection and production of biodiesel, it consists of inclusion of nano additives in the fuel and selection of nanoparticles and the engine setup, and preparation, stability, and methods. So techniques, addition of surfactant. And surfactant is nothing but which will avoid the agglomeration or the settling of the nanoparticles in the biofuel mixture. So the most common most common surfactant used is sodium dodecyl sulfate, SDS, SADS. Many are there, twin, AT, right? And ultrasonic vibration and stability inspection such as UV-Vis or zeta potential analysis, and characterization such as SEM, XRD, EDS, and TEM. And also we studied like the preceding experimental studies on the nanoparticles in diesel and biodiesel fuel blends. So these are the outcome of the literature analysis. So this I won't be explaining in detail. You can go to my profile, Google Scholar or Scopus, and see the article. And if anything you want to do research, continue your research, or thinking of doing some research, you can directly approach me. Okay. And we studied the dairy scum oil, honge, and the cottonseed biodiesel. And these are only the 3 examples. We studied almost like 20 of the biodiesel from non-edible and edible feedstocks. So here I'll just go to the next slide, pause. And also the methodology. So methodology is very important, So selection of a test engine. So test engine, we selected a CRDI engine and a normal diesel engine. And the materials which were used are graphene oxide nanoparticles, aluminum oxide nanoparticles, and zinc oxide nanoparticles. And the surfactant used is sodium dodecyl sulfate. And this we prepared dairy scum methyl ester, and honge oil methyl ester, and cottonseed oil methyl ester. I'll tell you in detail in the upcoming slides. And preparation of biodiesel with a very simple reaction known as trans-esterification reaction, and preparation of nanofuels and characterization tests such as ultrasonication, TEM, FESCM, XRD, EDS, etc. And final was the measurement of performance and emission characteristics. So these are the synthesis of nanoparticles. Since I told you in the previous slide that there are commercially available like Sigma Aldrich nanoparticles, but we prepared in the lab. So this is the synthesis of graphene oxide nanoparticles by chemical vapor deposition method. So this is a CVD chamber. You can see here, this is a CVD chamber. Here is a copper substrate. and there is a methane gas which contain graphene is nothing but one of the oxide of carbon, So here we pass the nitrogen and the oxygen. These are known as the precursors, and there is a reaction here. There is a reaction here, and there is a surface aggregation, dissolution, and precipitation, different reactions. So here they will settle on this copper substrate, the graphene oxide, at a temperature of around 1200 degrees, and there is a steady gas like rotating around the copper substrate. And when we remove the copper substrate and remove like uh, the deposition, and we powder it in a ball mill, so to get a finely powdered nanoparticles of graphene oxide. And this is the synthesis of aluminum oxide nanoparticles. This is zinc oxide nanoparticles. This is the aqueous precipitation method, so you can see here. And also there is a sol gel preparation of the aluminum oxide nanoparticles. And this is the trans-esterification reaction of like the dairy scum. The dairy scum, here you can see the dairy produces lot of milk waste which contains free fatty acids. So we just take the scum coming out of the factory, and we filter it, and add convert it into biodiesel by adding the KOH, potassium hydroxide, and methanol, and it will be stirred. There is a trans-esterification reaction. I will just explain in the upcoming slide. Here I'll show you. So here, South India, as I said, this tree, this is known as honge tree, and the scientific name is Pongamia pinnata. So you could have seen this type of fruits hanging on the tree. So it contains the seeds, which has a very high oil content. So it is grounded and the oil is derived. This is known as the honge oil. So in Kannada, they say honge oil. Okay, honge. So the honge oil is like dried here, magnetic stirrer to remove the moisture at 60 degrees centigrade. Okay, the water molecules and all will vanish from the honge oil, which is derived from the honge tree. And for the trans-esterification reaction, we use the hydrosulfuric acid, methanol, and NaOH, and here we heat it in a two-way round bottom flask, and here the actual trans-esterification reaction happens. Okay, for 60 minutes we had to heat it for 60 minutes. It is a very simple reaction. You can see here the honge oil is derived, or there is naturally, like in the market also you can get the honge oil or the jatropa or the sunflower oil. Anything, you can explore the biodiesel on any oil which has the free fatty acid content. Okay, and simple is like sulfuric acid, methanol, and NaOH, and heat here, and here for 60 minutes in a two-way round bottom flask. And here in the separating funnel, the top layer, will be always the oil. Okay, when you put oil on the water, you can see something floating on the water. You can see your face. So that is nothing but the oil. The heavier thing will settle on the bottom, at the bottom. So this is the glycerol. Glycerol can be used. It is a byproduct that can be used for the soap manufacturing, etc. And here the oil which is which is taken here, and it is known as the raw biodiesel. And the raw biodiesel is washed and dried, and it produces a pure honge biodiesel. Pure honge biodiesel. This is a very simple reaction. Just it will take 1 day to complete, to produce a biodiesel. And also our research is like preparing the nano fuel. So for this example, for this figure, we have taken the aluminum oxide nano particles, and we weigh, for example, 20 ppm or 20 milligram per liter, 40 and 60, three different like quantities of aluminum oxide, and we mix with, this is diethyl ether, or you can take just the normal distilled water, and this is the SDS surfactant. As I told you in the previous slide, the like SDS surfactant, the surfactant use is the application is to avoid the agglomeration or the settling of the nanoparticles in the fuel blend. So here we just send this mixture. This has the aluminum oxide, diethyl ether, and SDS surfactant, and we send to a bath sonicator. We sonicate this about 60 minutes. This sonication is required for the proper like blending of these three things, SDS, diethyl ether, and aluminum oxide. Okay, and from here we sent it to probe sonication for further blending, and also simultaneously we prepare the biofuel B20, biofuel B40, biofuel B25, biofuel B5. For example, biofuel B20, okay, we consider B20. B20 is nothing but 20% of biofuel and 80% of diesel. Okay, so we take B20, so 20% and 80%, and take in a flask, and like here we put the nano fluid which we generated here, and again bath sonicate, and again we send to probe sonicator. That like produces the nano fuel of Honge, biodiesel, and aluminum oxide nanoparticles. Okay, and further this is the thing. Okay, and this is the production of cottonseed biodiesel, and mixed with the zinc oxide. And this is the test engine setup. So here is the CMFIS conventional. This is a normal diesel engine, and we used the normal diesel engine and also the common rail direct engine ignition system, CRDI system. And also we modified the hemispherical. We used 3 hemispherical, toroidal, and toroidal re-entrant combustion chambers. And also the one hole, the single hole, can be changed to 3 hole, 6 hole, and 7 hole fuel injector. And the physiochemical properties of fuel blends. So these are some of the physiochemical, these are some of the standard equipments that can be used, that was used in our for the experimentation process. So we found out the density, kinematic viscosity, calorific value, cetane number, cloud point, flash point, pour point, sulfur content, copper strip, corrosion, and free fatty acid. So these are the some of the results. So for example, we used the DSOME, okay, discum oil methyl ester. 20 is the quantity. For example, this is biodiesel B20, okay, and 40 ppm of the nanoparticle. So this one gave the best results. And also the same thing we studied for the cottonseed. And these are the gas chromatography and mass spectroscopy analysis. So since we prepared the biodiesel, we didn't know what it contains, what type of fatty acids or what type of compounds it contains. So we need to make sure it contains the right quantity of the compounds, or the, I'll just show you here. So here you can see the fatty acids, and these are the DSOM. This is Honge oil methyl ester, and this is cottonseed oil methyl ester. Okay, these are some of the compounds, and like the grace of God, we like the manufactured, the produced biodiesel had all these properties with a standard biofuel. Okay, and these are characterization of graphene oxide nanoparticles. So you can see this is the SEM analysis, and this is the TEM analysis. These are the XRD. Since we manufactured in the lab, also we may need to make sure that this is properly synthesized. So also the XID, you can see the 001 peak, and these are the normal peaks for the graphene oxide. We compared with a standard JCPDS card, and this is the EDS analysis of the graphene oxide nanoparticles. Means the elemental, like how much carbon it contains, how much oxygen it contains. Okay, it is made up of graphene oxide is nothing but the compound of carbon and oxygen. Okay, and also this is the aluminum oxide nanoparticles. The same thing we did for the aluminum oxide nanoparticles as well. And these are the characterization of zinc oxide nanoparticles. So zinc oxide nanoparticles, these are some of the EDS images. And this is the XID, this is the UV-Vis, this is the FTIR analysis. And these are some of the TEM. So TEM analysis, we got it done in IISc Bangalore. And also this is the SAED pattern, and this is the HRTM image. So these are the performance characterization of Hongay and aluminum oxide nanoparticles, and dilithium and graphene oxide. So since we have very less time, maybe around 9 minutes remaining, so I'll just I'll just skip this part. Okay, so compared to, I'll just like briefly explain about these graphs. So when you include nanoparticle in the biofuel, okay, for 40 ppm, 60 ppm, or 20 ppm, it is way more better than using a biofuel directly in the engine. Okay, so the properties such as calorific value, flash point density, and so many properties like micro explosion, surface area to weight ratio of the nanoparticles mixed with the biofuel is better than a pure biofuel. So that is the thing. So we wanted to compare here. We compared the biofuel with the nanofuel here. So here you can see. So these are the carbon monoxide emissions, hydrocarbon smoke, nitrogen oxide. And here also the same thing for different nanofuels. So these are the combustion duration, ignition delay, and peak pressure. These are the like combustion characteristics of the diesel engine when you use the nanofuel. And here the same thing. These are the heat release rate, cylinder pressure, and the and these are the exhaust gas temperature, ignition delay, and peak pressure, and heat release rate here, cumulative heat release rate, and in cylinder pressure. So these are some of the using utilization of these nanoparticles plus the biofuel in the diesel engine improves the overall performance and reduces the emission from the diesel engine. And also there is a further scope. If you want to study in the same field, there is a further scope by using the artificial intelligence, okay, such as like optimization. You can take the results from some researcher. He will be very happy to share the results with you. So you can optimize, and you can, several things are there. You can use some algorithms such as dragonfly algorithm, like nature-based algorithm, wolf algorithm, so many are there. You can name your own algorithm by yourself and share it. So there is a further scope of study on this. Just you need lot of readings to study on this topic, So so this is a very important for the research scholar and who want to publish. So these are the things which I told about the hydrogen, and the basic about the hydrogen energy, and a detailed thing about the biofuels, research in the biofuels. So the main thing is to convert your idea to the publications. So I'll just tell in detail about this one. So it contains like master research writing basics, and we'll go through this one from research to publication and essential writing tips. So how to write a scientific research papers. Okay, so let's make a scientific writing engaging and effective. What is research? The creation of new knowledge and the use of existing knowledge in a new and creative way so as to generate new concept, methodologies, and understanding. So, this is a review process. This is a funny but like real type of, every author or researcher faces. So everyone wants to cut you down. So author, it's a very tough job to publish a paper, but the paper, if it is good according to the guidelines, journal guidelines, and some novel thing is there, then you can easily publish a paper. You can see here someone is holding the sword, some is holding a slab, someone is holding some hammer or something like that, some gun. Okay, so why writing matters? There is a saying, publish or perish. Publications are very critical for the academic growth, particularly for the people who have joined here. So sharing research advances knowledge globally and also key to professional recognition and impact. So advantages of research for university staff. So most of the universities in India, like they want a good NIRF ranking, what I understand from, and AICTE ranking, NAC, so many things are there. So also for the global universities such as QS or THE, I'm also the surveyor of the QS and THE. The main important criteria for a university for a good QS ranking is the number of scholars studying there and number of papers published in mostly Q1 journals. Okay, and for the university promotions, mostly where I work in the China, Lishui, Zhejiang province, or remaining all the China overall, they see the number of papers you have published in like more than 10 impact factor. They have a different ranking system known as Chinese Academy of Science, which is way more like difficult than the Web of Science Q1. For example, if like the Web of Science Q1 is 5 impact factor, they have a different criteria. Maybe 10 impact factor is the Q1 for Chinese Academy of Science. And also industry partnership. Publication often draw attention from industries looking for expertise in the specific areas, and also like future funding. Publication demonstrate effective use of previous funds, enhancing chances of receiving future grants. And there is the main thing, citation and influence. Papers are referenced by future researchers, helping guide further exploration in the field. There is a global recognition as top 2% scientist in the world. SciLit has newly launched from the MDPI, where only 5,500 researchers all over the world. And there is the most efficient and most there is 1% highly cited researcher. In that, only 6,500 from global researchers will be selected based on the publication, your impact on the society, and also like the Q1 papers, the citations. Citation is the main requirement for getting these global recognitions like 2%, 1%, etc. And these are the key skills involved in the research. So there is a basic computer skill, just like Excel or PowerPoint or Word. These are the basic computer skills. And also there are some softwares known as EndNote, Zotero, Mendeley, Origin, MATLAB. So many, like these are the basic computer skill which you should know. And you should think out of the box. There is known as critical thinking. Someone has done, for example, someone has used biodiesel, this biodiesel. You can use other biodiesel with further improving the properties or changing something. So that is novelty. You cannot become cannot bring something new to the society, but like you can just change a little bit in your research to publish an article, no problem. And this is the financial management. This is very important thing. Your university should support it for the financial thing or your own money. Okay. And summarizing the skills, you should know how to like do the experimentation and all. And as you are, as I know, all most of you are the full-time faculty. There is a time management between the teaching and the research. Most of the Indian faculty just like focus on the teaching. uh, what I suggest, like putting some time in the research also can gain you many things in the life, and also the precision. And I have used this Chinese language, so do not bother about this. And these are the guidelines for writing a successful research papers. And I'll come to the next slide. So questions to ask before starting: is the research novel and impactful? Okay, you have to think, you have to search several papers, you have to search the internet, ask maybe the chat GPT, is this impactful or novel? Okay, have I identified a gap in the literature? Some gap is there. If I use the solar energy, this PV cell with this material, can I use the other material with something like adding something in that material? So there is a literature gap, you have to identify that. And what journal and audience I am targeting. Okay, for example, if you are like doing the research on solar energy, there are several journals. Like the journal name is Solar Energy, the journal name is Solar Energy and Materials, and SETA, Sustainable Energy Technological Assessment, Renewable and Sustainable Energy Reviews, Energy Conversion and Management, Renewable Energy. So many are there. So you have to like identify the journal as well. And there are, numerous publications. Don't be like heartbroken when the article is rejected. There are so many, 33 to 40,000 active academic journals, and they are growing 3 to 5% annually. And also these are the commercial publishers such as Elsevier, Wiley, Springer Nature, Taylor and Francis, Sage, and Oxford Press, IEEE, ACS, RSC. And this is, I'll start with how to write a paper. So your paper should be IMRAD. You have to always remember this is the research IMRAD format, the backbone of scientific papers. So first one is the introduction. What's the research question? And second is the methods. Third is the result. And fourth is the discussion. And last will be the conclusion. So this is one of the paper. This is the paper which is highly cited in the Web of Science. And this is also highly cited in the Web of Science. I'll just come to the title first. Okay. The title, crafting the title. The title should be concise and engaging. You have to avoid jargons and abbreviations. Jargons means a specific like word. Okay. But the reader will not know the word. So you have to use a simplified or universal word which the user also can understand, And the second one is reflect core content accurately and search engine friendly with key terms. And here are some poorly constructed research paper titles with abbreviations, which makes very confusing. For example, you can just read the seventh title. Here you can see comprehensive analysis of BDF combustion characteristics in HCCI, CI engine utilizing TI2, NPS, CNTs, ZNOs, NPS. So this is so many full of abbreviations. So we don't know what is BDF. For example, I am the new researcher to this field. So I want to just read some paper. So when I open this, what is BDF? What is HCCI, homogeneously charged combustion engine? What is CI, TiO2? Okay, TiO2 is a universal. You can use this abbreviation, no problem. But what is NPS? Okay, nanoparticles, we don't know. And what is VLE, EGR, CFD? AI is okay. Okay, so you have to use the less abbreviations, you can use, but only universally known abbreviations you can use. So avoid cramming too many technical words in a single title. Use full terms for clarity, especially the abbreviation, as I told you. The title should provide a more clear and concise way. Okay, these are some of the excellent example of the research titles for the biodiesel, nanoparticle, and solar energy. You can see, for example, I'll read this nanoparticle. The first one, it contains a TiO2. Okay, this is a universal titanium oxide. So a formula of this: synthesis and application of TiO2 nanoparticles for enhanced photocatalytic degradation of pollutants under solar illumination. For example, the first one, catalytic conversion of waste cooking oil to biodiesel using heterogeneous catalyst, a sustainable energy approach. So simple, okay, and understandable to everyone, and it reflects the content of the whole paper. So this type of articles, this type of titles you should use in the research article. And also we'll come to the abstract, your paper's elevator pitch. Okay, so the abstract should be around 150 to 250 words, not around like most of the people, they just put everything in abstract or nothing in the abstract. So it should cover 150 to 250 words, and it should highlight the objective. It should be, everything about the paper, what is in the paper should come in the abstract. For example, the objectives, the methods which you have used, the results, and the conclusions. And also there, as you know, there is no figures, tables, or citation in the abstract. There is separate known as graphical abstract you can draw. There is some requirement of the journal, or it's mostly optional. So you have to remember there is 150 to 250 words in the abstract. And we will come to the introduction section. So in the introduction section, you can see provide context, why it is important, what the previous researchers have done in their work. Okay, and what was lagging in their work. What was lacking in their work? You can also add that. Okay, and what you are doing in your work. You have to identify the gaps in your work. And like in the end of the introduction section, you can write a statement that I am doing on this one, this thing, and this is very like I am doing this for first time or something like that. You can add it end of the introduction. And you have to please remember the abstract should be 10% of the paper. For example, if your paper is around 10,000 words including the reference, the abstract should be around 1,000 words. Okay, if your if your introduction is around 15,000 words, so your introduction should be around 1,500 words. So 10% of the whole paper. Okay, for example, one more example which most of the like researchers do nowadays. So since I have reviewed more than 500 papers in Web of Science, overall I have reviewed around 700 papers. But you can see here 1, 2, 3, 4, 5, 6, just like cited everything here. This is not feasible. Okay, very focused, very essential citations you can add. Maybe here you can see 1 or 2 or 3 or 4. Okay, and here you can see one of the bad introduction example. So since we are not the English speaking country, it is not our native language. For example, my native language may be Kannada, your native language may be Tamil. Some like India is a mixed culture. So English is not our native language, so we write what we talk. Okay, for example, the topic of renewable energy is very interesting. People have been talking about it for a long time because energy is important. Solar, wind, and biofuels are renewable, but there are many problems. In this study, we talk about biofuels. We also use nanoparticles in some experiments. The results are presented in the following sections. So this is one of the bad examples. I'll tell you in the next slide why. Okay. So what it lacks context and specificity. The introduction fails to provide a clear background or rationale of the research. And the statements are vague. Statements like people have been talking about it for a long time are too general and add no value. There's no explanation of why biofuels or nanoparticles are relevant to this topic. And no research gap or objective. This is very important. You have to add no research gap. So research gap can be found out by referring to the previous published articles. Okay, and what you're doing, what is the objective of your work. And weak writing style, the tone is overly casual and lacks academic rigor. Sentences like energy is important are simplistic and do not reflect thinking and fails to engage the reader. These are some of the things you have to avoid. And I'll come to the materials and the methods. So materials and the methods here. So the recipe for reproducibility. So you can see detailed description of experiments, tools, and data. You have to include everything. Okay, what you have used, for example, diesel engine, for example, the scanning electron microscopy, which like make, which is this one, and what methods you have used for production of biodiesels. Maybe include the actual figure of the engine, actual figure of the lab equipments, etc. And include ethical approvals if applicable. If you have used like derived something, for example, SEM image, scanning electron microscopy image from someone else, you have to properly cite it and take the permission from the journal and include the license number. Okay, that will be more better. And outline statistical and analytical methods. And I'll come to the result and discussion. This is very important. This is the main part which a reviewer sees in the paper. So results show, don't tell. Okay, use tables, figures to display key findings. You have to use very attractive figures, not very plain black and white figures. You have the figures which you use like attract, should attract the audience, and it should tell everything what is in their research as well, which will increase the aesthetic point of view of your paper as well as attract the audiences. And present fact without interpretation, organize finding logically, and use the clarity. Okay, and this is the conclusion part. The conclusion is very important. Discussion. What is conclusion? Whatever you had done, same like the abstract, like from introduction till the discussion, results and discussion, everything can be included in the abstract. But in the conclusion, what you have done in the result and discussion, you have to discuss what you have concluded, what is your result, what is your output. You have to add it in the discuss it in the conclusion. Okay, so first one is relate findings to the existing literature. Acknowledge limitations. You have to also acknowledge limitations of your field, of your study, and suggest next steps, and summarize the key implication without overreach. Okay, you have to not brag about your like research. This is like this, I am the first time who has done this and all. So you have to acknowledge also your limitation. What are the limitation of your studies, which were I'm not able to get this result, which was which was got by the previous researchers, etc. So these are some of the discussions in the conclusion sections. Here, I'll just read for you the poorly written conclusions in the biodiesel and solar energy. So in this study, we looked at the biodiesel and some of its properties. The results were interesting, but more research is needed. Biodiesel is important because it is renewable and it can be used instead of fossil fuels. However, there are challenges. We hope this research will help the people in future. This is very, very vague statement. Okay, this type of conclusion you have to avoid. And this much big, there is no result, nothing is there. This is the third one. There is no results. What you have got, like what you have concluded in your research, nothing is added here. And for example, this is generalized and vague, unclear impact, and no clear recommendations here, and lacks analytical depth. So one of the best written conclusion, for example, in the solar energy, this study demonstrated the potential of, you have to write here, specific solar energy technology approach. Okay, viable solution for this. And the result shows that your key findings you have to add, such as efficiency, cost effectiveness, and scalability. Make it a promising alternative to conventional energy sources. Furthermore, the analysis of these factors, environmental impact, performance under varying conditions, and economic feasibility. So this thing, see, lessons from these examples, like it summarizes key findings, okay, and emphasizes the broader implications of the research, addresses the limitations, provides the future directions, and closes with a visionary look. So this is the visionary look. By doing so, solar energy can play a pivotal role in achieving sustainable energy goals and combating climate change. Okay, and you have to, like, this is very important, as I told you in the previous slides. So tables and figures, visual excellence. You can use very beautiful tables. You can draw the tables using, for example, if you want to draw a table for the methods and all for the chemical reaction, there is a software known as ChemDraw, CHEM. For example, drawing, instead of using the Excel or the PowerPoint or the Word, you can use the Origin for drawing the graphs. Okay, and you have to avoid the duplicating information in the text and visuals. Some people just, like, for example, I have seen in my in the review in the papers which I review, they just cut from someone's same image or tem image and copy in their this one, and they don't, like, sometimes the reviewers will find out, most of the times they won't, but for their future the article might be retracted from the journal. That is a very big thing. You have to be very careful about the retraction as well. And this is the reference giving credit. For example, different journals have different styles. For example, APA style, you can take the Journal of Cleaner Production. It has a APA style. For example, IEEE numbered. So different type of styles are there. You can use, for example, you want to write a review article which consists of maybe 350 to 400 references. Okay, if you use manually each and every reference, it will take 3-4 days for you to change to the journal style. So just in a click, if you use the EndNote or Zotero or Mendeley software, you can use it, like just in a one click is sufficient. Okay. And also there are these are the styles. This is the style of the Journal of Cleaner Production, and this is the style of IEEE citation format. And for finding a journal, find a suitable journal. For example, Elsevier Journal Finder. I'll just click on this link. Okay, I'll just click on this link and we'll see where it will take us. So here you can see, for example, I want to match maybe keywords. Okay, I'll put maybe solar. It will suggest the journals where you want to publish. Maybe you have written your abstract, you can put your own abstract or the keywords here, and I'll find the journal. You can see, if you don't want the open access journal, just off this. Okay, so you can see the free journals here, maybe so solar energy materials and solar cells, Journal of Atmospheric, so many. Similarly, you can see Springer. If you want to publish in Springer Nature, then you can click here, Wiley. So there are like several of these journal finders, and here this is Trinka. This is a general, this one for all the Elsevier, Springer, Wiley, IEEE, ACS, this and all. So there are, you can see, there are several journals here in this research field, like just maximize. Okay, like Springer, Nature, Wiley, ACS, RSC, IEEE, etc. And there is also, you have to please remember, ethical and professional consideration. You have to avoid plagiarism and ensure originality. You can see in this figure, this guy is looking in a computer and just pasting it. Cut, copy, paste, you have to avoid. Okay. So you have to use the software such as Turnitin. Okay, this is a standard software for like checking the plagiarism or the similarity of an article. So avoid plagiarism, ensure originality. There is also plagiarism of the figures, as I told you, plagiarism of the tables you have to avoid. If you want to take the figures, if you want to derive and use it in your own research, please cite it. If you want to like copy the table, please cite the table as well. Okay. And you have to disclose the funding and avoid conflict of interest with the authors. For example, your university has paid the amount, the like research funding for you, okay, amount to do the research, but you have not like acknowledged the university. The university will approach the journal and there will be conflict of interest, and you have to avoid the conflict of interest among the authors as well. Some authors, they don't agree. You have to like take the authorship, like signature of all authors before you submit the, discuss with them, have a meeting. Okay, there shouldn't be any conflict of interest on the later on stages, and adhere to the authorship guidelines. And writing tips for success, and write clearly and concisely. Okay, use active voice and strong verbs. And finally, you have to like seek the professional feedback and navigating submitting a submission and review. So maybe I'll just tell in just 2 minutes. Okay, so here the first step is author submits the article and it will go to the edit. The article is assessed by the editor whether it can go for a review or it will be rejected. And if he agrees, he will send to the reviewers. If the reviewer agrees, if the reviewer likes your article, they'll give some comments. Okay, maybe it may be major comments or it may be minor comments. If they don't like, they will straight away reject it. If the editor, again, it will go to the editor, okay, the reviewer's comments. And if the editor likes the reviewer comments, maybe he will send it further. If he doesn't like, again, he will re-invite some few reviewers, or he may reject it based on the reviewer comments if the reviewer comments are too major or too harsh. Okay, and the review comments are then like reviewer comments, when you address the comments and it is again sent to the reviewers. If they agree, they accept the articles. And once the article is accepted, you have to wait for some time. After maybe 5 or 6 days, the copyright form will be sent to you. And you have to, after some few more days, the proof will be sent to you, and it will send after you submit the proof reading of the article, it will be sent to the production. After the production is complete, maybe 2 or 3 days, based on the company, based on the journal, the article will be published. And these are the few things, like top 2%. And final takeaways, you have to please remember, writing is a skill developed through practice. View it as an integral part of the research. Aim for clarity, impact, and integrity. So these are some of my 2% highly cited certificates. And this is my profile of Google Scholar, Web of Science, and Scopus. And thank you very much. Or if the time is a constraint, you can, if you have like interest in the research field, which I'm working on, or I'll just like take another 2 minutes. I work on the renewable energy, all the renewable energy, all the polymers, all the materials, all the AI ML. So my field is not limited to only the renewable energy. My field is diverse. Okay, so I have 300 different articles in mostly the different fields. So anyone like needs need help or need assistance in publication or maybe the research, I can guide them.
Sir, this is Godwin from Crescent Automobile.
Yes, Godwin. How are
I
you?
have a review. I have a question regarding the AI and ML part. So you told that we need a lot of data to publish our article in that AI and ML aspects.
Yeah.
Like, can you throw some more light on that? Like how to take the data, how to go with the regression part?
So AI ML, it has to, for example, if someone has like done the algorithm, prepared an algorithm, okay, the algorithm first you have to train the algorithm, okay. First
Okay.
training is required. For training the algorithm, you have to feed more data to the algorithm. For example, if I done some research on biofuel, maybe I have to like injection timing, injection pressure, so many things, maybe 10 to 20 things, maybe 300 to 400 readings you have to feed. Even less reading also you can feed, but the the results will not be accurate. As more readings when you feed to the algorithm, maybe to the software, it will give more accurate readings.
I think no questions.
So there is one
Shall I
question in
conclude,
the
sir,
chat
Julius,
box.
sir?
So there is one question from Jayvelu in the chat box. Professor, for the review paper, please explain. Maybe he is expecting some inputs for writing review paper.
Yes, sir. Review paper, it will take another session, to like how to write a review paper. But it's not too tough, First, you have to make an outline what you want to write. Study a few previous review papers. Maybe you take 10 review papers in front of you, take print out what is lacking in your review paper. For example, if the review paper is more comprehensive, more big, with more number of references, more number of data, more number of nice figures, there are more chances of its acceptance. So it will take a lot of time to explain about a review paper, because since I have written myself 5 to 6 review papers which are published in good journals.
So good evening, everyone. On the behalf of Crescent University and the organizer, I would like to express our heartfelt gratitude to our esteemed speaker for delivering such an insightful and engaging presentation on the application of hydrogen fuel in engines today. We are grateful to have you, sir, by joining with us virtually for this session. Despite the online format, you shared your deep knowledge of hydrogen fuel and especially on biodiesel technology in a clear and engaging way. Your explanation of the science, practical uses, and environmental benefits of hydrogen fuel as well biodiesel in engines was both inspiring and informative, sir. Your insights into the latest development in hydrogen powered engine as well as biodiesel, as well as the challenges ahead from production to the infrastructure, like advantages, modification of engines for hydrogen fuel applications and biodiesel, giving us clear understanding of what's to come. You have sparked our interest and encouraged us to think about how we can part of this clean energy shift. I would also like to extend special thank you to everyone who joined this online session. Your participation and thoughtful questions add a great value, sir. Once again,
Thank you
thank
very
you for
much.
this
Thank you very
speaker for
much,
your
everyone.
time, effort, and expertise. We greatly appreciate your contribution today, sir. And we look
Thank you very
forward
much,
to
James.
future opportunities to learn from you, sir.
Thank you.
Wishing
Thank you
everyone
very
a
much.
great session ahead. And thank you once again for making this online session success.